Hello everyone, welcome to my channel. Today we're solving min stack, which is LeetCode question number 155. So for this problem, we're going to design a stack, our own stack that supports push, pop, top, and also retrieving the minimum element in constant time. So the keyword here is constant time, which means that for getting our minimum value, we cannot iterate through the elements in the stack every time to get the minimum value. So that means that we need to refer to the top of the stack to do all these operations, especially the get minimum value. For that, we can have a node class that has several data fields, which we'll look at later as well. It's going to have the current value, pointer to the next node, and also the minimum value as well. So for this problem, there are 5 steps, but we're mainly going to focus on 1 and 2. First, we're going to create a node class and its constructor. And then we're gonna make the push operation, and the pop, top, and getMin operation is going to be really simple. So step 1, create a node class. So this node class, or the object, will represent each element in the stack, and it's going to have 3 data fields. It's going to have the value, current value, and a pointer to the next node, which will be you can also say below the current node. And we also have the minimum value. And this is a value when this node, or the current node, is at the top of the stack as well. And then we're going to have a constructor that initializes all of these data fields. And then we're also going to have a head pointer that will point to a node at the top of the stack at all times. But at first, we're going to have a new head pointer because the stack is empty. So then we can make our own push operation, and we're going to use these examples of push with value of -2, 0, and -3. And first thing we're going to do is we're going to create a new node to add to the stack. And once we do that, we're going to check if the stack is empty. So if the stack is empty, in this case it is, because it's our first operation, we're going to add the node to the stack with the value given, in this case -2. So we're going to add the value to the node, and then we're going to add the node to the stack. Next, we're going to set the next pointer. And since this is our first element, we can just set it to null because there's no next element. This is the only element in the stack. We're going to set the minimum value, which is going to be the current value, because again, this is the only element. So it's going to be -2 in this case. After that, we're going to update the head pointer. Now that we have a value in the stack, head pointer points to this new node. And in Java, it's going to look like this. We can actually do this in one line. Let's push another element. So we're going to push a node with 0 this time. So first we're going to create a new node, and then we're going to check if the stack is empty. In this case, this time it's not empty. So we're going to do something different. We're going to add the node to the stack with the value. So the value is 0 this time, and we're going to add the node to the stack. Next pointer this time points to the current head, which is the node below this new node. It's going to point to the current head. And the minimum value is going to be either the head's minimum value or the new node's value. So in this case, it's going to be either 0 or -2, whichever one is smaller. In this case, -2. So we're going to add -2 to the minimum value in the new node. And then we're going to update the head pointer. It has to be at the top of the stack at all times, so we can point it to the new node. let's add another element, and let's see, we can create a new node, and then stack is now empty. So we add the value to the node, -3 in this case, and add the node to the stack, and next pointer points to current head, and the minimum value is either the head's minimum value, in this case -2, or the new node's value, in this case -3. -3 is smaller, so we're going to add -3 to the minimum variable in the new node, and then we're going to update the head to the top of the stack. So that is basically the push operation. So next one, pop operation. The only thing we need to do is to move the head pointer to its next node. So we have to delete the node at the top of the stack, and to do that we can just move the head pointer to the next node, and technically the previous element is still there in some languages, but it's no longer referenced. We cannot reference it anymore, so we can say that it is deleted. And in Java it's going to look like head assign head.next. And top or peak operation will be very similar. We're just going to return the value at head. So in this case we're going to return 0. In Java it's going to look like return head.val. Lastly, the getMin operation, the only thing we have to do is return the minimum value at the head. Again, the minimum variable represents the minimum value in the stack when the node is at the head, so we only need to look at the head. And in Java it will look like return head.min. So that is basically it. If you want to see the code solution, you can click on this next video or click the link in the description. Thank you for watching.